I'm going to talk about cross-cutting relationships. And once again, this is another relative age dating principle. And it basically states any feature that cuts across a rock must be younger than the rock it cuts. Another way of saying this, whatever does the cutting is younger than what is being cut. So these are two ways of saying this. The second one's just a little shorter and easier. So this usually relates to faults, igneous intrusions, and unconformities, which represent erosional surfaces. There's another whole lecture on unconformities that goes over what they are in more detail, so I recommend watching that next. So it's pretty straightforward. I'm just going to sketch out another set of rocks here. Draw. So this right here represents a fault. And using the principle of superposition, I know that the rocks on the bottom are the oldest. So this is going to be 1, 1, 2, 2, 3, 3, and then the fault is 4. The fault is 4 because of the principle of cross-cutting relationships. It is cutting across layers 1 through 3. It's coming in contact with all these layers. Therefore, all the layers had to have been present when the fault occurred. So whatever does the cutting is always younger than being cut. So if the fault is in contact with the layer, because a lot of times what you'll get is just depending. Put the fault in first. So this would be 1, 2, 1, 2, 3. So this moved up, this moved down. There's no layer 3 here because it moved up and then got eroded, but there's a layer 3 here. So layer 3 had to have been present when the fault moved the rocks because it's being cut by the fault. Therefore, the fault would also still be number 4 because layer 3 is in contact with it. And whatever does the cutting is always younger than what is being cut. And then, okay, so then we can have an igneous intrusion. So just change this to red. I'm just going to draw an intrusion in. So equals igneous intrusion. If you're not going to remember, IgN represents igneous. Write out igneous intrusion. And then I'm just going to draw some layers. So using the superposition, I know that this is on the bottom, so this is 1, 2, and then the igneous intrusion cuts through layers 1 and 2, but not into layer 3, or this next layer, so this would be 3, 4, 5. 3 is younger than everything that is cutting, because remember, whatever's doing the cutting is younger, but it's not going into 4 and 5, so therefore 3 came before 4 and 5. That's how it works. And then if we draw, just going to draw another one. And so once again, this is an igneous intrusion. Anything is red, I'm making an igneous intrusion. And then I'm making this wavy surface. So this represents an unconformity, which is an erosional surface. It's missing time. So using this, once again, the principle of superposition, 1's the oldest. Then using the principle of cross-cutting relationships, the igneous intrusion is cutting across layer 1, but doesn't cut across the unconformity, so this would be 2, then the unconformity would be 3, and then the layer above it would be 4. So the unconformity is number 3 because of the principle of cross-cutting relationships. It's cutting across 1 and 2, but not 4, so, and then superposition says 4 is on the top, so 4 is younger. So that's another example using unconformities. Then I'm just going to show you another one that students usually have issues with. Because igneous intrusions intrude from deep into the earth up into rocks, they come from below. So once again, red equals igneous intrusion, and we'll make purple metamorphic rock. And we'll make this a metamorphic rock up here. So a lot of students would say, okay, based on the principle of superposition, the red is 1 and the metamorphic rock is 2. That's not correct because igneous intrusions intrude into rocks, and generally what you would get, they hopefully will show you some baking. But they might not. And so, but the fact that this is a metamorphic rock and you have an igneous rock, if this rock is a metamorphic rock and you have an igneous rock, if the igneous rock was formed first, this would have been metamorphosed when this rock was metamorphosed. So since this is an igneous rock and this is a metamorphic rock, I know that the igneous rock is younger than the metamorphic rock because it would have metamorphosed with it. So using the principle of cross-cutting relationships, the igneous rock is cutting into the metamorphic rock, and therefore the metamorphic rock is older than the igneous rock. So this is kind of a special case because it's talking about metamorphic rocks. All the rest of these rocks that are on here in black, or the black and white area, are all sedimentary rocks. Are the black and white, the black outline layers. So the sedimentary rocks, this doesn't hold true with. This only holds true with metamorphic rocks, but the igneous rock is intruding into it. So because it's metamorphosed, the igneous rock would have been metamorphosed along with the other rock that was present, and they both would have been metamorphic rocks. So I know the fact that this is an intrusion is intruding into the metamorphic rock, so the metamorphic rock is older than the igneous intrusion.